43. Today I'm messing around with some stepper motors as generators. They will make electricity if you spin them. I've got this one coupled with a rubber piece of rubber tubing to an electric motor. I'm running the electric motor off from 12 volts. Just something so I can spin the stepper motor. That could be done in numerous ways. You could actually get really scaled up and make one that spins outdoors with the wind. You could connect it to your water supply in the house, maybe with a little impeller pump that works backwards. And there's all kinds of ways you can harness energy. I've got one on my bicycle I'll show you later that lights up some LEDs and makes a self-contained, self-generating bike light. But right now I'll show you what I have on the workbench here, and I've set up a few little experiments so I can show you some stuff about stepper motors, induction, AC, DC, full wave rectification, and all kinds of fun stuff. Let's get started. Here's the test setup that I've put together. There's the stepper motor being driven by an electric motor coupled together with just a rubber coupler that goes in there so the motor can spin the stepper motor. That way I can generate electricity off from this 4-pole stepper that has a common ground. Those wires all run over to the breadboard and go in right here, and then they jumper over onto the bridge rectifier circuit. That's 4 diodes arranged in a classic bridge rectifier configuration. Out of that comes the DC rectified voltage here and here, and then I have a 7.5K resistor there to simulate a load. That way I can pick up the DC voltage that comes off from these two. And I've also got my voltmeter set up here so I can check voltages. I've got a little experimental stuff happening here. We're going to see if we can charge a 9-volt battery with this output. We're going to try to spin an electric motor with the output. I've got an LED, see what happens with that. You saw a little bit of that in the beginning of the video. And a capacitor to charge up. So let's get the camera set up, pointed at the oscilloscope, and I'll show you the AC waveforms first, and then we'll go to the rectified DC. Let's take a look at the voltage DC before we go to the oscilloscope. I'll fire this up to get the probes on, and you'll see the readout right there. There we go, about 43 volts roughly. DC voltage after the rectifier. Let's look at the waveform on the oscilloscope. Zoom in on that a little tighter. You can see the reticule and the readout. It's 43 volts, so if our baseline is right here, let's see, I'm at 2 volts per subdivision. There's 5 of those per square, so that's 10 volts. So there's 0 volts, 10, 20, 30, 40, plus 3 more. So that's 43 volts. That's the readout on the scope. DC. Now let's take a look at the AC waveforms. Okay, we'll look at them first with the ground connected to the common ground, and I'll show you one pole at a time. Let's go ahead and move this up on the screen a bit. So there's one of the poles. They're all isolated right now from the bridge rectifier because that will affect the readout here. And there's another one. They look pretty much the same. That looks about the same. They all look the same. Kind of a sawtooth wave. Now let's connect to two of the poles on the stepper motor and not a common ground. There's one waveform. That's one pair of poles. Oh, there's another one. See, that one kind of goes back to the sawtooth, and that one's kind of a hybrid. And so is that one. So these are two that I'm thinking these are the ones that are in phase, or maybe out of phase with each other. So they make a sine wave. And these two are in phase with each other, perhaps. That's why I see a kind of a modified sawtooth sine wave. It's kind of strange. Now let's try connecting this slightly different here, see what we get. Now there's the other two poles. They look just like the other two matched ones. So going off from that, if I take that output as one side of my waveform, and then take that output as the other side of my waveform and connect them to the bridge rectifier, we'll get the DC voltage. Let's do that now. Okay, we're connected back up to the bridge rectifier now. There's our DC voltage, full wave. If it was half wave, every other one of these waveforms would be missing. We'd only see part of it. So it's a full wave bridge rectifier. We've got 48 volts coming out of there. So let's do a few little experiments here and see what we can do with that 48 volts. Rectification, rectification. What is all this rectification business about? Well, this circuit below is a full wave rectifier circuit. Half of an AC waveform is rectified here. The other half of the AC waveform is rectified there. This is the motor generating a sine wave. That stepper motor spinning around. It's making basically an AC current sine wave like we saw on the oscilloscope. Well, it has a polarity that's positive or negative and changes sign each half cycle. When the direction of the current is from the generator into the bridge at point C, then the only available current path through the bridge is C, B, A, D, with the current running through the resistor right to left. During the next half cycle, the current direction is from the generator into the bridge at point D. Then the only available path is D, B, A, C. But again, the current is running through the resistor right to left. The resistor in this circuit represents a load on the DC current. So we could put a motor in there like we did, charge a battery, do many things with that DC current. But this is representative of the load right here. So that's rectification in a nutshell. Okay, we've got a little electric motor connected to the output, and I'm running it through my meter. I've got it set on milliamps, and so I need to use this probe to actually get the power to the motor, and then we can watch how many milliamps the circuit will put out. It's definitely not amps, it's only milliamps. So here goes. Whoops, I need to power it up first. Looks like it peaked out at about 43, and now it's got a running amperage, milliamperage of 37.4. But there's not a lot of available torque on that motor because of the lack of amperage. So it'll run a motor, but it runs it without a lot of torque. Very little amps. Let's try LED next. Got a white LED mounted right here. Runs through the meter again so we can watch the milliamp draw. Let's fire up our stepper motor. Connect up the LED. And you can see that it lights up and draws about 31 milliamps. Okay, so we can light LEDs. That's pretty cool. How about a 1000 microfarad 25 volt capacitor? Can we charge that up? Well, let's check it out. Negative to negative, positive to positive, and I believe that's it. It's charged up. Let's disconnect power. Let's take our little experimental LED here and hook it up and see what we get. Indeed, we get some power out of that capacitor. Cool, so we can charge capacitors. Wonder if we could charge a battery. What do you think? Okay, here's the battery. Let's fire up our little power plant. And there is the battery charging away. Let's take a look at the voltage right now and see what we've got while the battery's charging. The voltage dropped down to 10 volts, so the battery's definitely making a load there. Go ahead and let that run for a little while here and keep track of the time, and then we'll come back and see just how charged up it got. Okay, that was about a 5-minute charge. Let's see if we can spin a motor with it now. Indeed we can. So we just charged up that battery a pretty fair amount. How about that? Let's look at how much voltage we have in the battery. .45. So you can charge batteries with these little stepper motor generators. That's pretty cool. There's a lot of neat things you could do with a stepper motor as a generator. You just need a way to spin it. So an idea that I've had for a while, I've had a hard time implementing, would be to power the stepper motor from a water turbine, and the water turbine is run by water running through it from your house supply water. Every time you turn your water on, the turbine would spin the stepper motor, and it would be enough to charge batteries for your cell phone or laptop or whatever, you know, just slow charging type things, not high demand current. There's quite a few things that we have in our lives that are devices that don't require a lot of amperage to be able to charge them up, just some available voltage. You could also connect one of these to a wind generator, like a propeller, a big fan in your backyard. You could do some gear reduction on it and spin the motor faster. This is a small motor too. There's plenty of other ones out there that are a lot bigger. In fact, I have a little collection of them here in a drawer. Got all kinds of them. Stepper motors are all over in lots of electronics, mostly in printers you'll find them, things like that. This one looks like it's a 6-pole motor. So we could probably do some fun things with that. Here's another one just like the one I'm experimenting with. Came out of a Dell printer. There's another one here that's a 4-pole. This one could potentially put out some pretty good voltage. Let's take a look inside a stepper motor, see what is happening in there. Alright, I've got our little LED on the 9-volt battery we charged up. Let that sit there and run while we go through this. This is a stepper just like the one that's mounted on the board, and this one I've ahead of time taken apart. Inside are where all of the windings are for the poles. Each one of those little triangles is a separate winding, and as you see, there's a row of them with 2 different directions to them. Those are also different poles. There's another row down there, so there's the 4 poles that we have on the output, plus the common ground. And then here we have a magnet. that spins around. This looks like it was just, a regular old magnet, circular magnet. You can't really see in the video, but this is actually, I can see lines where it's divided up, and I'm thinking that each one of these is a different pole in between there. I'm not 100% sure on that, but at any rate, these step in increments of just a little bit at a time, depending on what kind of pulses go to these poles right here. So you might just pulse it once and it will align itself where the attraction of the magnets is north-south on everything, and it will just bump one part of a degree. They vary quite a bit from stepper motor to stepper motor as to how far in degrees they move on each impulse. But there's all kinds of them out there. There's tons of information available for driving stepper motors. What we're doing here though is turning them into little electricity generators. So I'll take you on a little tour now of one of these that I mounted on my bicycle with some available parts at hand, and just kind of hacked it on there and made a bicycle generator that lights up an LED so I can see where I'm going at night and cars can see me. Let's take a look at that. Our LED still glowing strong. Three-speed, my old three-speed bike. It's got the stepper motor bike light generator on it. It's just pivots right there on a simple little mount I made with a hose clamp and some bits and pieces I had laying around, and a spring. Flip it around, you can see the spring there from the other side. Yeah, that works. So that just rubs against the wheel, and then that rubber tire turns the stepper motor, and it just rubs against the rim as you cruise down the road. And then I tapped into the let's see, how did I wire this? I almost forget, it's been a while, but it's the 4 poles and a common ground, and I just grounded the common ground right to the frame of the bike, and then the 4 different poles go out, and you can run 4 different LEDs, and they can be different, value LEDs and everything. It'll work just fine. So up here in the front I made a single little front headlight. That reflector is a spacer from a drum kit. Drummers will know what that is. And then the wires, let's see, continue on up and down the top tube back here, and they go to a red tail light that I got really silly with one day and put 2 red LEDs in Mr. Teddy Bear tail light. You'll see him in a while. And up front on each fork is a little side marker light that kind of looks like basically like the turn signals or running lights. So it kind of creates an illusion at night when you see the 2 side marker lights and the one on the top. People kind of think you're a bigger motorcycle. And of course the little teddy bear tail light. Well, this week's hack was kind of fun, playing around with this stepper motor. I've been wanting to do this for a long time. The bicycle project actually happened I think almost 2 years ago now, and it's been a while since I shared that with anybody. I had it on my other channel. I figured I'd sneak it over here into Hack a Week, and at the same time explain a little about what you can do with stepper motors besides just use them to make maker bots and stuff like that with. They're really cool for generators. You could wind this thing up with a hand crank if you had to. This is totally zombie apocalypse stuff here. You've got some wind power and stepper motors out of some old printers, whatever. Get enough of them, you can set up your little wind farm on your warehouse where you're hiding out from the zombies. Okay, so a little homage to the zombie people I know out there. You know who you are. Albert had a good time here. He's got his own little power plant now to oversee, so he's happy. He's going to have the German engineer in him is going to have a good time. Well, anyway, I hope you enjoyed the hack, and I encourage you to get out there and find some stepper motors and set them up on the bench like this and play. I'll post the schematic for the full wave rectifier on the website. Meanwhile, there's people downstream that need to watch, you know, their big screen TVs, so I gotta get the power plant back up. I'll see you later. Keep on hacking.